Coming up with This Week in Computer Hardware, you're not crazy, people. Apple did slow down your old iPhone. It's a battery thing. Magic Leap is showing off hardware, promising a ship date, and NVIDIA's Titan V. We got more benchmarks from that $3,000 GPU. All that and more coming up next on TWiCH.
Netcasts you love.
From people you trust.
This is TWiCH.
Bandwidth for TWiCH is provided by CacheFly at CACHEFLY.com.
This is TWiCH, This Week in Computer Hardware, episode 445, recorded December 21st, 2017. Apple did slow down your old iPhone.
This episode of This Week in Computer Hardware is brought to you by Rocket Mortgage by Quicken Loans. Home plays a big role in your life. That's why Quicken Loans created Rocket Mortgage. It lets you apply simply and understand the entire mortgage process fully so you can be confident that you're getting the right mortgage for you. Get started at rocketmortgage.com/twitch. And by GoToWebinar, a trusted webinar platform with over 55,000 customers who have hosted over 2.7 million interactive web events to connect with their audiences. For more, visit gotowebinar.com/podcast.
Welcome to TWiCH, This Week in Computer Hardware, TWiCH's weekly show that aims to bring you a whole giant mess of hardware news. It's our second to the last episode of the year. CES is about to fall upon us like a breaking wave. And the big news in Ryan Shrout's life is figuring out just exactly how much computation you get out of the NVIDIA Titan V, the $3,000 GPU that NVIDIA doesn't want anybody to review, but Ryan pulled the cash out, got the mayhem on, and he's done a second round of testing. We should point out, outside of the incredibly out-of-control price, it's a pretty fantastic gaming GPU. We talked about it last week on This Week in Computer Hardware, episode 444, if you'd like to know how it compares to, for example, a 1080 or a 1080 Ti, should you have all of the cash and none of the motivation to run two cards in your system. This week, you got kind of crazy with compute performance. What's the word,
in
man?
two different angles. It's interesting. So NVIDIA doesn't want people to review this because we're all idiots, right? So the idea is they would send us the part, and we would, of course, we would test gaming on it first or only, which we absolutely did. But after I spent money on the card, whatever, it's up to us. The truth is that benchmarking and evaluating performance for non-gaming workloads is a much less well understood science. It's much less common. We do it way less frequently, so it is a more difficult thing to have to do, right?
Right. And I don't think they were worried about you testing the card with games and being obnoxious about it. I think they were worried about people doing the sort of dollar per frame rate calculations they do for more traditional GPUs and calling it a ridiculous waste of money.
Correct.
Not quite the marketing spin they want.
No. And I completely understand that from their point of view. It's just, it stinks from our point of view to have to spend the cash in order to bring the story. Hence, while we're doing as much testing as possible, because if you're going to spend $3,000 on a part in order to try to get an ROI in terms of story coverage, you're going to do this a lot, like as much as possible type of thing. So as we look at part two of this, which is compute, we look at things like OpenCL rendering, double precision compute. We look at benchmarks like in the second page, you got Luxmark, which is a path tracing, ray tracing rendering that uses OpenCL. And what you'll notice is that the Titan V is 78% faster than the Titan XP, right? So significant performance deltas exist in some of these cases, right? But if you look at something like Cinebench, the next one down, it just uses standard old OpenGL, right? The old graphics language. And other than the performance gap that exists between the AMD and the NVIDIA hardware, no big change really from that. V-Ray is a rendering application that uses CUDA. So the NVIDIA specific kind of programming models for NVIDIA GPUs, and then it uses OpenCL for AMD GPUs, and this is a lower is better result. And clearly there's a 25% advantage for Titan V. Yeah, but yeah, it's like 3 times over the AMD part. That being said, I will say that the CUDA version of V-Ray has been around for an exceedingly long time, whereas the OpenCL version is pretty new. So in terms of optimizations, chances are OpenCL has just not really been worked on nearly to the amount that the CUDA versions have. So, take that for what you will. Now, the next set of tests we looked at was Sysoft Sandra, which is generally known as a processor, a primary CPU synthetic test, but they actually have a lot of really good synthetic tests for GPU processing as well. This graph here, I think, summarizes things pretty well. This is GPU compute. So this is shader-based, normal FP32 compute capability, or I'm sorry, shader-based, but single and double precision. If you look at the single float shaders, the set in the middle, the Titan V is faster, but not by a significant margin. I mean, it's probably still 30, 35%, 20, 30% performance delta for the Titan V versus the other two. But if you look at double float, double precision floating point shaders, the gap is not a typo. That is legitimately a 14.7x increase for the Titan V over the Titan XP, and a 6.6x increase over the Vega 64. Now, people might be wondering, like, how is that possible? How does that much of a performance delta exist? It comes down to what is known as the ratio of single precision to double precision compute. If you look at most modern gaming GPUs, they emphasize single precision performance because that's what gaming game engines and processing utilize. Double precision is only used for things like compute, financial analysis, physical modeling, stuff like that. And in order to save power, in order to save cost, in order to improve yields, these gaming-centric GPUs will run at significantly lower capability and double precision. So you'll see things like the Titan XP or the GTX 1080 Ti have a 1/32nd ratio, or a 1:32 ratio of single precision to double precision. It basically means there is 1/32nd as many shaders that operate on double precision as there are that operate on single precision. So that drops your performance quite a bit as you move between those compute models. On the Titan V, it is targeted towards this audience specifically, so it is a 1/2 ratio. So while it has 5,120 standard CUDA cores, it has 2,560 double precision compute cores. So if you look at it, I think it's 2,560 for the Titan V, but only 256, no, even less than that, 120, I think, for the Titan XP. So now you get an order of magnitude difference in compute capability, and that's where those numbers come from. And if you scroll down through those other results, you look at financial analysis, you look at scientific analysis like in-body simulation or matrix multiplies. These are workloads that take advantage of double precision compute, and where you see performance advantages of 13x or 14x, right? It doesn't happen in every test, but in tests that utilize it, it is a huge gap, right? And that is why people wonder, how can NVIDIA get away charging $3,000 for add-in cards? That is why you can get away charging $3,000. If you're doing physical modeling, if you're doing financial analysis, $3,000 is an item on a spreadsheet of your cost, right? But if you can do something 10 times faster than you could do with a different card, it's a no-brainer decision to really dive into.
No, I had a friend who did networking stuff for Wall Street firms, and he's like, I find them a 1/10 of a second, a 1/4 of a second, they'll cut me a check for $1 million. To whatever the cost of the hardware upgrade was, a little bit here, a little bit there. It's amazing. Or if you're currently spending 17 hours rendering something, and this turns it down to 7 hours or 3 hours or 70 minutes or even 12 hours, that's a huge reduction, and you can iterate that much faster. That's a big deal. I get that.
It is. It is. So the other thing worth mentioning is if you look at like our SpecView Perf results, which is SpecView Perf is kind of this industry standard professional application workload evaluation tool. So things like SoftWorks or Maya or CATIA, 3D Studio Max. This is kind of an industry standard way of benchmark those. You'll notice there's not a very big difference between the Titan V and the Titan XP there. Most of those applications are using single precision compute, so the performance delta is not going to be very much. Also, these are the types of applications that generally have specialized, specific pathways through the driver, optimized in the driver specifically for 3D Studio Max. Chances are this hasn't been done for Volta yet, because Volta as an architecture hasn't really been released as a Quadro level product yet. So my guess is if we check back in this in 6 months or a year, these will be 25 or 30% faster on Volta compared to Titan XP. Just a guess. You know, like the folding at home showed the same thing. If you do double precision compute, you just, you know, huge jump and increase there. So, excuse me, that's kind of like the compute side. And then actually just today, you know, I don't know, this one's even more complicated for people who are used to following gaming. If you look at part 3 that we published, it is deep learning performance. The other thing to keep in mind about the Volta architecture as we know it is not only does it include standard compute processors, it also has tensor processors in it. It has tensor cores. It has, I believe it's 120, right? Let me, yeah. It has 640 tensor cores built into it. And tensor cores are specialized processors that compute. What's the definition here that Ken put in this? They accelerate tensor-based math by utilizing half-precision FP16 math in order to process both dimensions of a tensor at the same time. And if that's too much for you to grasp, or I'm doing a very poor job of explaining it, which I probably am, the idea is that this is a math profile that is very common in deep learning syntax. Right, so anything that is AI, artificial intelligence, or machine learning based is likely going to use some of these capabilities. And because Volta was built for double precision math, machine learning, these very adaptive changing workloads, NVIDIA kind of surprised everybody by implementing a different type of processor into a GPU. Right, so it's almost like adding a co-processor of 640 of these tensor units into what would have normally been just a standard graphics-based architecture. Now, as a result, Ken spent a lot of time in the last week or so figuring out how to benchmark machine learning, and it's a very different beast than something we're used to, right? So it's all Linux-based. You have to install a whole bunch of different applications and work environments. One of the things that NVIDIA does really, really well is they launched something called the GPU Cloud, which is basically you install your NVIDIA driver on your system and you download this package that basically configures your system to run machine learning, as long as you're running an NVIDIA GPU, obviously, very quickly and very easily. And it's for people, even, and I take this in myself, put myself in the same category, I have no experience doing this. It takes it from this incredibly complex idea of configuring files and downloading different packages that you have to configure to work together to simply downloading one thing, running it, and boom, you have a working environment. That's just that's one of the things NVIDIA does really well, right? Is package things so that it's easy to use, and then they hope that pushes the adoption of their parts going forward. The other complication is you have to download, well, depending on what you want to test, we downloaded a 150 gig industry standard work set, right? So it's basically 150 gigs of pictures that you then put through these training algorithms that create a deep learning neural network, or a neural network through deep learning on whatever it has, recognizing a dog or what have you. Long story short is, again, the Titan V shows its advantage in these instances, right? If you look at TensorFlow, if you look at GoogleNet, all these different kind of networks that exist, the blue bar that is FP16 of Titan V, running at 531 images per second versus the fastest Titan XP could do is 231. So more than twice as fast as the Titan XP doing this, significantly faster than what the Vega Frontier Edition can do on these same work sets. We use Caffe 2, which is a similar benchmark or similar work set, but is the deep learning algorithms put together by Facebook, for example. And again, Titan V kind of tops out at 553 images per second, whereas the Titan XP tops out at 235. So similar ratios and scales across the board here, indicating another place where, hey, this is a reason this card is $3,000. There's a reason why people are willing to pay for this type of compute. I don't know how many of our listeners are into machine learning. I'm sure there are some, and I'm sure it's a growing field, right? And the idea is with a Titan V, you have the ability to install this in your own PC and start work on whatever project you have imagined up using it. You use the NVIDIA cloud to easily set up your platform for it, and you go. It's still an expensive card, but if you're going to make money on this stuff, as you mentioned your friend doing stuff for the financial groups, when your business is based around the performance that something like this can provide, $3,000 makes a lot more sense than if you're playing Destiny 2, I guess. It's impressive, right? Like, this is the first time we've ever dove down into this world, and it took a long time to kind of get up and running. I know it's always a pain for me financially and mentally to realize how much time we spent figuring out how to benchmark these things and evaluate them. And in the end, we produced 4 images, 4 graphs of data, right? But the truth is, it's really impressive numbers, right? And AMD has a pretty long way to go to catch up, at least with these standardized work sets. So I don't know. I rambled for a long time on that. It's an impressive product, but it's got a very specific audience, I think is fair.
Good to know. Yeah. If you're looking for a little bit of an SSD upgrade before the end of the year, Alan has some excellent news for you. His review of the Crucial MX500 SATA SSD reviews, or as he titles it, make SSDs affordable again. How about 26 cents a gigabyte for a 1 terabyte hard drive? We're talking about $260 for 1 terabyte hard drive, a 2 terabyte hard drive for $500 MSRP. Not quite to Ryan's goal of a good, healthy 10 cents a gigabyte, but certainly leaning in the right direction on that one. Currently, the only one that's available at Crucial's website or up on Amazon.com is the MX500 1 terabyte version. Well, it was available. There it is, $259.99 at Crucial.com, or you can go up to Amazon for, again, $260, $259.99, available pretty much immediately, which has me thinking about a computer I'm running right now that has a mere 256 gigabytes. One issue with the drive that Alan pointed out, which was the trim speed, which is something he started looking at. For example, if you delete a giant file and you notice your write times, your drive performance, your system basically seems to hang afterwards. These are pretty good example of, he discusses pretty thoroughly in the trim speed section of his performance comparisons, where he's looking at like, okay, so, he captured a huge amount of drive activity on this, in the task manager up towards the top, if you take a look at that, where there's like a 16 gigabyte file being deleted and IO on the drive completely stalls, right? It maxes out. So they've started looking at trim speed, file delete, under load, seconds per gigabyte. So for the MX500 1 terabyte, is the only thing more awful is a BX100 500 gigabyte drive. But if you look at the numbers, right, it's like more than twice as long as an MX300. We're looking at like almost 5 times as long as an M600. Math that I can't do in my head because it's so many, like nearly an order of magnitude compared to some of the Samsung drives. Latency percentile data, essentially, right? They're doing a little workload and then seeing what happens in terms of erasing the file. So, if you are constantly deleting large files, you may find this a little irritating unless there's a fix for that Crucial can do in firmware. But the endurance is competitive. The overall performance and performance consistency is solid. The cost per gigabyte is outstanding. And if you've been, waiting for the prices to move a little bit in the SSD market, Crucial, it seems, is trying to kickstart that whole field. Or as Mr. Malventano says, the SSD market certainly needed a good kick in the pricing, and the MX500 has certainly delivered, which is not how he speaks at all. But I think you get the point. MSRP again from Crucial, MSRP coming from Amazon. So that's 26 cents a gigabyte for a 1 terabyte hard drive. $260 for 1 terabyte hard drive is awesome. And it's got a modern controller, Micron NAND and DRAM. This is pretty awesome. So if you're looking for an inexpensive drive, this is badass. Their 500 gigabyte drive promises to sell for $140, but again, the 250, 500, and 2 terabyte models are not currently available. And, it's gold because of the trim speed issues. But I'm excited. I'm looking at upgrading right freaking now. Or at least as soon as I get done with the podcast, I can start shopping. I shouldn't be ordering and podcasting at the same time. Oh my goodness. It's dangerous. Wait a minute. Did I really order this? This won't fit me. Who did I buy this for? This episode of This Week in Computer Hardware is brought to you by Rocket Mortgage by Quicken Loans. Mortgages, they're complicated, they're painful, they're not keeping up with the times, right? It's a dated process. It favors the bank, there's no focus on you. You're the client. You're going to be paying money for 30 years. You'd think a little technological revolution would take place, and it finally did, right? That's why Quicken Loans created Rocket Mortgage. It gives you the confidence you need when it comes to buying a home or refinancing your existing home loan, because it puts the tools in your hands. No more carrying your hat in your hand, going to talk to the woman or man at the bank who's giving you that, should I really give you this money look? It's simple. You can fully understand all the details. Be confident you're getting the right mortgage for you because the details are there. It's convenient. Trusted partners allow you to share your financial information with Rocket Mortgage at the touch of a button, so you know what's going where. It's powerful. Whether you're looking to buy your first home or your 10th, Rocket Mortgage is able to perform thousands of calculations in seconds. Based on your income, your assets, and your credit, Rocket Mortgage can analyze all the home loan options for which you qualify and find the one that's just right for you. Rocket Mortgage by Quicken Loans. Apply simply, understand fully, mortgage confidently. And you should be confident when you take out a mortgage. Nobody wants to be scared and nervous. To get started, go to rocketmortgage.com/Twitch. That's rocketmortgage.com/TWiCH. Equal housing lender, licensed in all 50 states, NMLS consumeraccess.org number 3030. And we thank Rocket Mortgage by Quicken Loans for their support of This Week in Computer Hardware. Oh my goodness. Apple admits to messing with iPhone performance. Yeah. Mr. Ryan Shrout tweets, "This is substantial news. The reasoning for the performance drops is confirmed to be the battery, but does this mean Apple is designing silicon to require voltage spikes higher than its designed battery system can supply over time knowingly?" That is a complicated sentence, sir.
It is. So the background of this is, so for many years, people have complained and theorized that Apple was somehow purposely slowing down their devices in order to incentivize them to upgrade to the next generation of iPhone, right? So there's always this kind of feeling that people had that their phones were getting slower over time without a whole lot of proof as to how or why or anything like that. So recently, what happened, actually, this all happened in the span of like 2 days, which is amazing. Somebody on Reddit was complaining about their phone being slower than they thought it would be, and benchmarking it and kind of showing that it didn't match the performance scores that these phones indicated they would have when they were new. Turned out he also saw lower than expected battery life. When he replaced his battery, the performance scores went up, right? Which prompted John Poole, who's one of the developers at Primate Labs that makes Geekbench, one of the most popular kind of performance evaluation tools for mobile devices and for PCs too now, where they went back through a whole bunch of data and basically showed here's what you're looking at, the iPhone 6S, right? If you look at the expected performance level, right? If you look at those two graphs, actually, that's enough to show you what you're looking for. iPhone 6S version with iOS 10.2 and then 10.2.1. And what you see is those humps that exist, lower humps off to the left of the main spike, indicate that there is some portion of devices that are now scoring at that range as opposed to the peak range. And this all happened over the, literally from 10.2.0 to 10.2.1. And as you scroll down through, you'll see a lot of these changes continue to, shift. So now with 11, the iPhone 6S, you can see that more of them are actually scoring slower than they were before, right? And the same thing is happening on iPhone 7 as well. And the battery replacement that put it back in line is kind of what triggered this shift, right? And so then Apple came out with its official statement, basically saying that our goal is to deliver the best experience for customers, which includes overall performance and prolonging the life of their devices. Lithium-ion batteries become less capable of supplying peak current demands when in cold conditions, have low battery charge, or as they age over time, which can result in device unexpectedly shutting down to protect its electronics components. If you remember, I guess it was last year, 2 years ago, when we had this rash of people whose phones were just suddenly turning off, your iPhone, and I had it happen to me too. I'd be using my phone. It had like 40% battery. I'd open up an app and it would just shut off. But then I could just turn it right back on and it would seem to be fine. This was a result of that. So last year, this is going back to Apple, last year we released a feature for the iPhone 6, 6S, and SE to smooth out the instantaneous peaks only when needed to prevent the device from unexpectedly shutting down during these conditions. We have now extended that feature to iPhone 7 with iOS 11.2 and plan to add support for other products in the future, essentially saying that they're going to take this policy for 7s, 8s, X's, 10s, whatever, iPhone 10s. So what's happening here from a technical standpoint is the Apple processor in any of these phones, when it wants to spike very quickly to its top frequency in order to respond quickly to a user input or whatever, right? Any kind of performance request, it draws a significant amount of current to do so. So what happens is, as a battery ages, its ability to provide its peak current degrades over time, and it degrades as the charge of the battery is lowered as well. So what Apple saw was happening was that, say, an iPhone 6S running this benchmark, opening up a certain application, doing whatever, was trying to pull more power from the battery than it could provide, so the device shuts down to protect itself. That all makes sense. So what they did was, in the software, they were now limiting what the peak frequency of the processor was, so that the processor could not request or try to draw more current from the battery than the battery could actually provide. As a result, performance goes down. What you feel like, not just in benchmarks, but in how you're using the device, right? The peak frequency of the SoC is now reduced. And as you saw from those graphs where there are multiple peaks, multiple humps, it was doing it in multiple steps. It wasn't just like, oh, we took it from 2.2 to 2 gigahertz. It was like, well, okay, if the battery was at state 1, it was at 2 gigahertz. If the battery was down to state 2, we take it down to 1.8 and then down to 1.6 or whatever. I don't know the exact numbers, but it's clear that they were monitoring the kind of average or median battery output capability over time and adjusting in software through these software updates and lowering maximum performance in order to prevent, damage to devices or unexpected shutdown. So the conspiracy theory that we've had for so long that Apple was releasing software updates to lower your performance as new phones came out was 100% true. It's just, it wasn't a conspiracy. It's not a conspiracy theory that they're doing it to force you to upgrade. They're doing it for a different reason. Now we can have a different discussion about whether or not they should be doing that, or they should have been more transparent, or how they're going to message that going forward now that it's been discovered and kind of proven and they've admitted to it. That's a totally different thing. But for me, my first takeaway is, okay, people actually weren't just crazy and full of crap, because we've had these discussions many times, right? About my phone feels slower, right? If my wife is on an iPhone 6S and the iPhone 8 came out and iOS 11 comes out and she thinks it gets slower, and I go, no, it didn't. You just feel like that because you want the new phone, blah blah blah. Turns out, no, she's right, and it did get lower because they released a software update that saw that her battery was degraded to some point, and to prevent her from having her phone shut down unexpectedly, they lower her peak performance.
They could have warned us. They could have said, hey, if you're running into, it could have been like, given everything they're doing inside of the operating system, given the fact that they knew this was a problem, given the fact that they initiated performance degradation to prevent the system from shutting down, they also could have advised you that, your battery has reached a certain state where if you want continued high performance, you need to update or upgrade the battery. And they didn't. I find this incredibly irritating. Yeah, they did not.
So there's even more. There's even a more I don't want to say insidious, but like an even more troublesome idea that you could extrapolate from this, in that they knowingly designed a system, a combination of your processor and your battery, understanding that this would occur, and understanding that what they really wanted was, on reviews of day one for the first year, while this is the flagship and while they're trying to sell a lot of them, they want this to be the fastest phone in the world, no questions asked, right? Take no prisoners performance. Right. And then they'd be like, you know what? We understand that over time that it can't sustain that. So the solution is either this software hack that they have kind of integrated, or they design a system which is a processor performance level and a battery system that can be sustained through the life of the device. And you can define that if you want it to be 3 years or into a decade, which is probably unreasonable. But if Apple were to limit the performance of their SoC so that it would never, after a year, it was never going to get slower, right, than what it is, they would never have to do that, then in theory, they wouldn't have had this problem. The performance would feel the same. They wouldn't have to issue these software updates and patches to go along with it. The negative to them would be that their phones wouldn't be that much more faster than the competition. But in my mind, generally the Apple SoC for the last 3 generations has been considered so much quicker than the competition that this is easily something they should have decided to do a while ago, right? Hey, you know what? Let's make our processor 10% slower on purpose, knowing that we'll extend its performance life to 3 years instead of 1 year. And that's a decision they could have made, and I think they should make. Whether or not they will, or they continue to push down this path, I think is something we'll see. I mean, we'll see with the iPhone 8, we'll see with the iPhone 10. They've already put their foot in the ground. They put their stake in the ground and on those devices once they're launched. But with whatever comes out next September, will they take this into consideration when they develop that and pitch it and sell it and go into advertising and all their perf stuff? But
this is me not holding my breath.
Yeah, I can see that.
I can see that. Intel is thinking of living it up a little. Such an odd title for Intel, right? It's funny because we did a best of 2017 episode to wrap up Tech Thing for the year, and I thought about AMD's Ryzen was number 1 on my list, and the 8th gen Kaby Lake refresh actually was a big deal for me because it effectively for multi-core stuff. It delivered a near doubling of performance, pretty huge performance increase in ultra portable laptops, which is a big deal to me. I like what Jeremy writes in this quote, Intel's recent releases have not been terribly exciting. The chips offer small incremental efficiency improvements each generation with a few enterprise level features added, which do not benefit enthusiasts. And that was my big point when I put Ryzen number 1 on my list. It was like, oh, wow. Somebody remembered that there's enthusiasts who need performance and will pay for it, and then delivered a bargain price for it and got a whole bunch of attention for that. What's going on with Krasanik seems to, feel like they're going to maybe embrace the desktop market again? I mean, do they care?
It's not even that they've said that they're going to embrace the desktop market. They basically the reason this came up was he released a memo that went out to all Intel employees, and obviously it got out to the media,
as it does.
It's talking about changes that were coming to the company, that they felt like they needed to take more risks, that they needed to be more aggressive, right, that they were going to start being the underdog in many of these areas, and they needed to act like it, right? They needed to be more forward-looking on these types of things. I think that applies to both the PC market, the consumer compute, whether it be laptops or DIY PCs or gaming machines or what have you, but also from their point of view in the server space or in autonomous driving or in machine learning, right? They're going down this path of taking risks, figuring out what works, and then moving on, I think is one of the lines in there, right? So that you figure out what works and you move on, which would mean you have to have a corporate mentality that it's okay to fail as long as you can recognize it early, cut it off, and move forward, right? And then proceed on to the next thing. Iterate, update, iterate, update. That's not really been what Intel has done for the majority of the last decade, to be fair.
Right.
Not that they didn't try new things. They tried to enter the mobile space to compete with Qualcomm, right, and Apple, and that didn't work out. They tried to, it's probably been just about 10 years when they tried to do GPUs the first time with Larrabee. That didn't really work out. But if you look at the spaces where they've had leadership positions, desktop processors, server processors, even storage to some degree, right? The X25M, when that came out, was like the leadership SSD. They really kind of sat on their heels and did not innovate, with left the door open for AMD to build Ryzen, Threadripper, Epic. It lets, if you look at AMD's mobile space, if you look at NVIDIA taking over, adding in discrete graphics across the board, kind of replacing Iris Pro. There's a lot of, Epic coming into the server world, Qualcomm coming into the server world. There's a lot of places where they didn't do this. They didn't do what was necessary to maintain leadership positions. And as a result, I think you saw in 2017 a lot of their primary channels being challenged. Which, when you're a stalwart blue chip company that's they're almost 50 years old. It's hard to imagine, actually. Intel's almost 50 years old. Change is difficult. It's like turning a cruise ship versus turning a speedboat. I think it's going to be a pretty interesting thing to watch in 2018, how much of this is actually realized. Because the idea of finding out what works and moving on and quickly making bold decisions and not trying to be perfect, but trying to be fast and address these markets, hungry and aggressive, as that quote says right there. That's something you think of as like, hey, Google used to be this way, or Facebook used to be this way, and these kind of like software-defined companies have this flexibility. But when you're a hardware-defined company, it's much more difficult to be as nimble, right? When you're developing process technology that takes 5 years to get to market, that can be a problem. To suddenly shift directions, right? That's what happened with Pentium 4. It took a long time to correct that mistake. Now, they haven't made any of those types of mistakes over the last several years, right? It's not like they're that far behind, but just from a mentality standpoint, they need to shift. So I think Intel CEO Ryan Krzanich has gotten a lot of flack for seemingly being at the helm during this time when they're just being attacked from all these different angles. And so he feels like he needs to go on the attack himself. And preserve Intel's placement in the market. So I don't know. I don't know if this means in 2018 we're going to get. I mean, think of what they've already kind of started to do, right? They announced an Intel processor with Radeon graphics built into it. They hired Raja Koduri to build discrete GPUs. They've done some stuff, I'd say, in this last quarter that really shows that this was the idea going into 2018, I think.
No, that makes sense. And it's been frustrating, I think. Intel's done this spectacular job maintaining these huge margins and this huge presence certainly in the mobile market, but at the same time they completely flubbed. Phone or mobile computing in the cell phone sense of it. They don't seem to have the place they wanted to in terms of Internet of Things. They didn't do what everybody expected them to do with their ARM licensing to kind of propel the company into this area where the primary interface, to computing or the internet was going to be, is now essentially an ARM device. Although, whether or not anybody knows that, they probably associate whether it's going to be Qualcomm or one of the other ones. I think it's going to be really interesting, right? You did an article on Tech Pinions, where the world's going to run on Intel Silicon, and it's going to be interesting to see, right? Because he's talking about making a fundamental change in the way Intel works, and they've certainly done that. The deal with AMD is pretty spectacular, and the hires are pretty spectacular. I think it's going to take, because it's going to be interesting to watch, right? Because they're going to be competing with, AMD while they're working with AMD, while they're still trying to figure out, sort of an Internet of Things, forward movement. They've done a lot of noisy things, but it seems like they haven't done a lot of the base grunt establishing of products that people want to integrate into huge volumes. And part of that is because these huge volume products are using the least expensive processors available, or the most, the ones that are the most battery efficient. And the Intel has not done a great job with that. I don't know. I'm curious. I'm curious to see where it goes, and we wait with bated breath, ladies and gentlemen.
We often do.
It's a lifestyle. This episode of This Week in Computer Hardware is brought to you by GoToWebinar, the webinar platform that's hosted 2.7 million interactive web events with over 60 million views per year. That is a lot of eyeballs looking at a lot of activity, people. GoToWebinar believes webinars are one of the best ways to interact with your prospects and customers instead of business presentations or company websites. You don't have any control on a website. You can't react. You can't hear what your client, your prospective customer is doing. But with GoToWebinar, you can create custom email invitations, confirmations, and reminders, or you can let GoToWebinar handle it with automated email templates. They're going to make it as easy as you want them to. Display your company logo and custom image on all webinar materials. Create and schedule pre-recorded webinars that are as interactive as live events. It's mobile friendly, right? People do a lot of stuff on their phone these days. You can schedule a webinar, edit a session, or track performance from your iOS or Android device. Create up to 20 polls before the session or on the fly for audience interaction. You can add up to 20 questions to a survey and engage participants with Q&A. Engage your audience with more than one presenter and panelist. Up to 6 presenters can share their webcams and participate face-to-face. You can broadcast a view of your desktop or a specific application. And with GoToWebinar's reporting and analytics, you're just a click away from qualified leads, metrics, and data to improve webinars. You got end-to-end 128-bit AES encryption, and they are rated #1 in customer satisfaction. Turn your next presentation into a conversation with GoToWebinar. For more information, visit gotowebinar.com/podcast. That's gotowebinar.com/podcast. And we want to thank GoToWebinar for their support of This Week in Computer Hardware.
Indeed.
Oh my goodness. So Magic Leap, we talked about them having raised more venture capital than half the planet. For an AR device that no one had seen, that is often described in terms that I will affectionately describe as over the top. And the Magic Leap is finally, they've revealed the One Creator Edition. So they got the goggles, the LightPack computer. It's kind of a puck that the CEO Roni Abovitz claims is equivalent to a MacBook Pro or Alienware gaming PC. That's the puck there on the left side. There's a single controller, but Magic Leap One Creator Edition apparently supports, quote, multiple input modes, including voice, gesture, head pose, and eye tracking. It'll persistently map objects into your environment. And I find it amusing that Rolling Stone got the first hands-on look. Which says a lot about where Magic Leap is going with this. And there's an interesting article on The Verge, right, where Magic Leap also invited Pitchfork, right, to its studio. And the title is Magic Leap invited Pitchfork to its studio, and the results are maddening. They have been so secretive. They sort of don't acknowledge the rest of the VR or AR industry, right? Because last week on Tech Thing, Shannon used her Google Pixel phone to put AR porgs all over our set. A, because she loves porgs, and B, because she's got a Google Pixel 2, and that was the update they got. Microsoft, you may have heard of Microsoft, is working on this. All the major PC manufacturers have released AR compatible visor systems. So Magic Leap has an interactive music experience, and I think it's I think it's going to be really interesting to watch, right? Because Magic Leap uses a ton of NDAs. They've been very, very secretive. They don't have pricing. They don't have a ship date. They claim performance that,
I also I also feel like they haven't even determined what their business model is going to be yet, right? The only time I've actually used a Magic Leap device is as an add-on to a Qualcomm standalone VR headset, right? It had a Magic Leap hand recognition and implementation on it that worked really, really well, but it was more VR than AR. And but anytime somebody brought up AR VR, this company was always at the top of the list, but it was also always at the top of the list of companies that you think will never actually produce a thing and will somehow walk away with investment money and never ship. It's hard to look at where they're at now and maybe say that, right? They claim shipping in 2018. They've got pictures of an actual device. Looks a little goofy, but hey, whatever works. I like the idea of that thing on the left there is actually the compute pack. So rather than trying to put all the compute in the headset, it's actually something you wear on your belt, right? Which it helps power everything.
Wireless. Yeah, it implies a wireless connection to the headset. But we're talking about a company at this point. We're talking about a company at this point with $1.88 billion in investment. Like, how do you even begin to pay that off?
I don't know.
What I mean? That means everybody on the planet needs to buy these goggles. Immediately. They've been talking about how it was going to be this cinematic experience. And certainly the founder has done some amazing things. He basically worked in a company that did, robotic surgery arms, and that sold for $1.65 billion. So there's no doubt that, Rony Abovitz takes some pretty mystical, crazy ideas. We're going to put a surgeon across the planet. He's going to operate a robot. It's going to do surgery. You know what I mean? That's don't get me wrong. I'm not trying to mock that. I'm like, that's pretty amazing. But, it's also, this seems like a very strange, way to bring a product like, the kids are going to love this interactive musical environment. It's an extraordinary experience for the funds because nobody's been doing this. It's like, okay. This is not exactly the most novel use of a VR environment. Magic Leap is, quote, going to replace everything that we know, phones, TVs, and computers. That's what one of the band members that created the experience claimed about it. I would like to see them actually ship a real product, or
I would.
Or show up at CES or show more that Wired got to look at it last year, but not talk about the hardware, just what it looked like through the hardware they had at that point. At this point, we have pictures of hardware or renders of hardware, with the crew at Rolling Stone and Pitchfork writing about it. And if you aren't familiar with those magazines, they're music magazines and culture magazines. The cinematic, the pictures they released with the strange Porg-like watermarking in the corner do not look cinematic in terms of realistic. And we've seen a lot of stuff. We've seen a lot of what I will affectionately call staged, less than real world stuff coming out of, for example, Microsoft, when they did a bunch of their demos that implied that, there would be this full cinematic experience that would be wall to wall, like you were staring at a giant virtual reality. And then it turned out we were looking through, sort of a box like this, and this was our entire, we could look at this much VR or AR at a time, not VR, AR. A lot of marketing fluff, a lot of joy, no price, no ship date. The CEO insists it will ship in 2018. They also insisted they were going to ship an SDK back in 2015. And as far as the SDK hasn't actually shipped yet. But it'll be interesting to see. 3GPP has declared the first 5G NR spec. They say it's complete, which means we'll probably be hearing a lot more about that at CES. The idea is that 5G was going to be done next summer, but the industry who's pushing really hard for the 5G new radio spec because they really, really want to start shipping 5G products. So it is complete. Certainly Qualcomm has had a huge amount of input on this. 1 gigahertz, 607 megahertz, all the way up to 50 gigahertz. The 3.5 gigahertz band is in there. And then the standalone version will be completed in June 2018. It's going to be the user and control plane capability for 5G NR, more on the network architecture, how that's going to work. I think it's going to be really interesting to see. Quote, says Fierce Wireless, AT&T was among those who were pushing for the accelerated standards work early this year. It was extremely aggressive, and people put in an awful lot of extra time and effort, and it looks like we've made it. Dave Wolter, AVP of Radio Technology and Strategy at AT&T Labs, told Fierce Wireless Tech earlier this week, we believe we're at a point where silicon manufacturers can begin their designs and start developing silicon. So it'll be interesting to see if this works, if this accelerated development process is as good for consumers as it is for AT&T. So,
fair.
Bloomberg says that Apple's building an EKG monitor for its smartwatch, and I just wanted to point out that that's got to hurt for a LiveCore and the Cardia band that a LiveCore makes, at least if Apple goes for FCC approval. And it's good to know that Apple is still mining its partners for opportunities to introduce useful things into its core products.
Yep.
Yep. So I just want to give a shout out there for a LiveCore who has, I should say FDA approval. Sorry, not FCC approval. Excuse me. A LiveCore has FDA approval for their EKG devices that work either with your iPhone or with your wrist. It's pretty cool. I just think what a LiveCore is doing is fascinating, and I would like to see them, still be a company even if Apple integrates this directly into the Apple
good
Watch.
Luck with that, huh?
Oh my goodness. I wait with bated breath. Next week, ladies and gentlemen, our 2017 end of the year wrap up. We'll be hitting. Ryan and I will be spending quality time with our families before the glory that is CES. If you got CES questions, if you're thinking about buying something, if you want to know what's going on with Intel and AMD and NVIDIA and all the rest of the PC world, do us a favor. Tweet at Ryan Shrout or at Patrick Norton. We'll be paying attention to our feeds, or at least I will. Ryan generally pays attention to his feed in between meetings. Yeah, sure, whatever. I don't want to make promises you're not ready to keep.
I appreciate that.
I try. I don't know if we'll be recording directly from the. I don't know if we'll be recording This Week in Computer Hardware directly from CES, but we'll do our best to get the information to you as quickly as we can. I will be there with massive headgear and devices in place because Robert Heron and I will be recording an episode of AV Excel from somewhere in the show. Hopefully somewhere.
We should talk about that then, I assume.
We should talk about that. With that, ladies and gentlemen, this obvious sign of end of the year mayhem and preparation. We want to thank you, as always, for listening or watching This Week in Computer Hardware. If you're new to the show, go to twit.tv/twitch to get all the links to subscribe and all of our older episodes. And hey, you can find more of Mr. Ryan Shrout over at PCPer.com. You can find more of me at TEKTHING.com. That's techthing.com, or avexcel.com, which is the home theater podcast I do. Tech Thing is oddly enough about tech. I know that sounds crazy. And yeah, looking at CES, we've got announcements from AMD, from NVIDIA, from Intel. The list could go on for hours. But how about we talk about that after it happens in 2018? Thanks again, everybody. I'm Patrick Norton.
I'm Ryan Shrout.
We'll see you next week on Twitch.